Prepare for an extraordinary, possibly cataclysmic event that could forever alter our understanding of the universe. One of the most massive and enigmatic stars in our cosmic neighborhood is sending signals, deep, unsettling signals, that something momentous is about to occur. Betelgeuse, the colossal red supergiant looming at the shoulder of Orion, has begun to behave in ways no astronomer expected. It's not just the fluctuations in brightness or the color changes that are setting off alarm bells. Through the penetrating eyes of the James Webb Space Telescope, scientists are now seeing detailed evidence suggesting that Betelgeuse is nearing the end of its life, and that end might come in the form of a spectacular supernova. The consequences would be breathtaking, not just for science but for everyone who gazes up at the stars. Dr. Brian Fields, an astrophysicist who has studied Betelgeuse for decades, has issued a sobering warning. What we are witnessing may be the first stages of a stellar collapse so powerful that it will light up the sky even during the daytime. We're talking about an explosion that could rival the full moon in brightness, that would dominate our skies for months or even years. But with that excitement comes fear. Because events of this scale are unpredictable, and despite the distance, roughly 642 light-years away, the implications are massive. Could we really be on the brink of watching a star die, live and in real time? Let's pull back and understand why this moment is so important. Betelgeuse isn't just any star. It's one of the largest known to science and certainly one of the most famous. Nestled in the Orion constellation, it's been a fixture in human culture and mythology for thousands of years. But it's not just its placement in the sky that makes it remarkable. The scale of this celestial giant is nearly incomprehensible. Betelgeuse is about 764 times larger than our Sun. Let that settle in for a moment. If it were to replace our Sun in the center of our solar system, its outer edge would reach far beyond Mars, engulfing Mercury, Venus, Earth, and the red planet in a sea of turbulent plasma. Imagine looking up at the sky and seeing not a bright yellow disk, but an enormous, burning red expanse stretching from horizon to horizon. Betelgeuse has reached the red supergiant phase of its life, a brief and violent stage in the life of a massive star. After spending millions of years fusing hydrogen into helium, it's now fusing heavier elements in increasingly unstable reactions. This phase doesn't last long in stellar terms. Whereas our Sun is expected to live for around 10 billion years, Betelgeuse, with all its grandeur, will live only about 10 million years total. And it's already around 8.5 million years old, which means its clock is running out. What makes this more eerie is that Betelgeuse is already cooling. Its surface temperature is roughly 3,500 Kelvin, significantly cooler than our Sun's 5,500 K, which is why it radiates with that unmistakable deep red glow. It's the color of an aging giant, a dying flame flickering before the final burst. But it wasn't always like this. Ancient records tell us that Betelgeuse may have once shown a different color altogether. If you could go back 2,000 years, Betelgeuse might not have looked red at all. Historical texts from Roman and Chinese astronomers describe it as yellow, which is significant because stars don't change color unless something dramatic is happening within. By the 9th century, Arabic scholars were writing about its reddish hue. This shift, from yellow to red, over just a couple of thousand years suggests that Betelgeuse has been changing fast on a cosmic scale. Fast enough that our ancestors saw it evolving before their eyes. This dynamic nature has made Betelgeuse a subject of intense study for astronomers. Its brightness has always varied, but what makes it especially compelling is its unpredictability. It's classified as a semi-regular variable star, meaning it goes through cycles of dimming and brightening. The primary cycle lasts about 400 days, but longer fluctuations happen over a 5-year period. That in itself isn't too strange. Many stars pulse in brightness. But Betelgeuse doesn't always stick to the rules. Sometimes the pattern breaks. That's what happened in late 2019. Astronomers all over the world noticed something startling. Betelgeuse began to dim, not just a little but dramatically. It lost a noticeable chunk of its light in a matter of weeks. By February 2020, it had reached the lowest brightness level ever recorded in human history. This event, now known as the Great Dimming, sent shockwaves through the astronomy community. For months, theories flew across journals, forums, and headlines. Some speculated that a massive eruption on the star's surface had thrown up a cloud of dust, temporarily blocking its light. Others believed it might be the early warning signs of an impending supernova. Amateur astronomers trained their telescopes skyward night after night, capturing the transformation in real time. Even in cities drowning in light pollution, Betelgeuse's dimming was visible. That's how significant it was. And yet, the mystery only deepened. Because when we observe stars, we're not seeing them as they are now, We're seeing them as they were decades or even centuries ago. Light takes time to reach us. The photons streaming from Betelgeuse tonight actually left the star more than 600 years ago. So when we witness an anomaly, we're looking at the past. The actual present-day condition of the star? That remains unknown. This is why the latest observations from the James Webb Space Telescope are so important, and so chilling. Unlike its predecessors, Webb is capable of observing stars like Betelgeuse in infrared, peering through the dust and gas that might otherwise obscure our view. What it has found is deeply concerning. Complex motions in the outer layers of the star. Turbulent convulsions in its atmosphere. Enormous pressure waves rippling across its surface, far more powerful than anything recorded in the past. It's as if the star is heaving and gasping in its final breaths. Scientists have long known that when stars like Betelgeuse near the end of their lives, they go through a phase of violent instability. The fusion of heavier and heavier elements creates tremendous internal pressures. These pressures build until they become unsustainable. Eventually, the core collapses under its own gravity, triggering a supernova, a cosmic explosion of unimaginable power. This isn't just a flare or a solar storm. It's a fundamental unmaking of a star. When a supernova goes off, it releases more energy in a few moments than our sun will emit over its entire 10 billion-year lifespan. The shock wave obliterates the outer layers of the star, blasting them into the cosmos. What remains depends on the star's mass, a neutron star, or if it's massive enough, a black hole. So what will happen when Betelgeuse explodes? It won't harm us. Despite being relatively close in galactic terms, Betelgeuse is still over 600 light-years away. That's far enough to keep Earth safe from radiation or debris. But the light show will be unforgettable. The explosion will be so bright it could be visible during the day. It may even cast shadows at night. For weeks or months, it could outshine every object in the sky except for the moon, and even rival that. People will look up and see a second, fiery point of brilliance illuminating the heavens. But beyond the spectacle, the explosion will also provide an unprecedented scientific opportunity. Instruments all over the world, in orbit and on the ground, will tune in. It's a rare chance to study the death of a star in real time, and to unlock the secrets of cosmic creation. Because supernovae don't just destroy, they also create. They forge the heavy elements that make planets, oceans, and even human bodies. Every atom of gold, every molecule of iodine, every speck of calcium in your bones, those were born in a supernova. Possibly one like the one Betelgeuse is preparing to become. And yet, as we wait, we're left with awe and uncertainty. Will it happen tomorrow? Or not for another 100,000 years? No one knows. But the signs are there. The countdown may already have begun. The light we see from stars doesn't come to us in real time. It takes time, years, centuries, sometimes eons, for light to travel across the vacuum of space before it reaches our eyes. Betelgeuse, one of the most iconic stars in the night sky, is located roughly 725 light-years from Earth. So when we observe it, whether through powerful telescopes or with the naked eye on a winter night, we're not seeing it as it exists now. We're seeing it as it was in the 1300s. That's the strange truth about stargazing. It's not just observation, it's time travel. Every twinkle from Betelgeuse is a message from the medieval past. And any transformation it's undergoing now, if it has already exploded, if its light has already erupted outward in a spectacular finale, we won't know until the light from that moment finally arrives. This is the light travel time effect, a fundamental principle of astronomy that turns the entire universe into a kind of ancient archive. It applies to every star, every galaxy, every supernova we've ever seen. Even the most advanced telescopes cannot escape this cosmic delay. It means that as we puzzle over the behavior of Betelgeuse today, we're really interpreting history, while simultaneously trying to predict a future that, for the star itself, may already have happened. And yet, despite this paradox, astronomers have not stopped trying to decode the mysteries of Betelgeuse. If anything, the lag has made the pursuit even more compelling. In the wake of its dramatic dimming event between late 2019 and early 2020, global attention turned to the Orion constellation like never before. That sudden drop in brightness, visible to amateur observers even in light-polluted cities, was like a cosmic whisper, and scientists around the world leaned in to listen. At the heart of this investigation was a team led by Andrea Dupree at the Center for Astrophysics, a joint project of Harvard University and the Smithsonian Institution. They turned the Hubble Space Telescope toward Betelgeuse during this period of change, capturing rare and invaluable data on the star's outer atmosphere. What they found was stunning. The outer layers of Betelgeuse were shedding material at staggering speeds, close to 200,000 miles per hour. That ejected mass didn't just vanish into the void. It condensed, cooled, and formed a veil of dust, a cloud thick enough to block a significant portion of the star's light from reaching us. This was no ordinary puff of stellar wind. It was a massive event, a convulsion of solar plasma unlike anything ever recorded on a star of this kind. It appeared that Betelgeuse had effectively coughed out a chunk of itself, a burst of superheated plasma that escaped the star's surface, expanded outward and cooled into microscopic dust grains, forming a dense shroud between the star and Earth. That's what dimmed its light. And while the light returned to normal in the months that followed, the implications did not fade. This immense ejection of material led to intense speculation. Could this be the prelude to the end? Was this vast stellar burp a sign of internal turmoil, a last gasp before collapse? Some astrophysicists saw it as a sign that Betelgeuse might be entering the final unstable moments of its life. Moments that could stretch for decades or even thousands of years, but which signal the beginning of the end. The sheer magnitude of the event underscored its significance. Estimates suggest that the amount of material ejected during the Great Dimming was over 400 billion times the mass of a typical coronal mass ejection from our Sun. That's not just an anomaly, it's an eruption of biblical scale. A wave of plasma and dust so enormous it temporarily rewrote the star's identity in the sky. And for those watching closely, it may have been a silent scream, one final message encoded in brightness and shadow, in particles and light. Of course, this raises the inevitable question: when will it happen? When will Betelgeuse finally die? Astronomers are cautious. Some suggest the star could go supernova within our lifetimes. Others argue it might hold on for another 100,000 years. The truth is, we don't know. Stellar lifespans are hard to predict, and Betelgeuse is particularly stubborn when it comes to conforming to models. Its vast size, complex behavior, and irregular light cycles make it a puzzle that defies easy answers. But the overwhelming consensus is that it will happen. Betelgeuse will go supernova. The only question is when. And when it does, the spectacle will be unlike anything humanity has ever witnessed. The explosion, a core collapse supernova, will occur when Betelgeuse's core, having fused elements all the way up to iron, can no longer support the crushing force of its own gravity. That moment will happen in a heartbeat. The core will collapse inward at unimaginable speed, while the outer layers explode outward at thousands of kilometers per second. The light from this explosion will race through space, growing brighter and brighter until it reaches us, flooding our night sky with fire. The energy released in that instant will be so immense, it will outshine every star in the sky. Betelgeuse will blaze like a second sun. It will be visible even in daylight. In some regions it might be bright enough to cast shadows. For weeks, even months, it will remain visible in full glory, a cosmic lantern burning in defiance of death. But even as it dies, Betelgeuse will be giving back. The explosion will hurl into space the very elements that make life possible: carbon, oxygen, nitrogen, iron, and more. These atoms, born in the inferno of a dying star, will drift through space, eventually becoming part of something else: planets, oceans, DNA. In a very real way, supernovae are the alchemy of the cosmos. Without them there would be no Earth, no trees, no blood, no bones. We are, as Carl Sagan once said, made of star stuff. And Betelgeuse's death will be another chapter in that cosmic cycle of creation and destruction. But even beyond the poetry, the scientific potential is staggering. Observing a nearby supernova in real time would provide data scientists have only dreamed of. We would be able to test our models of stellar evolution, better understand the life cycles of massive stars, and observe the birth of a neutron star, or possibly a black hole, just 725 light-years away. Telescopes on Earth and in orbit would shift focus immediately. Neutrino detectors would wait for the silent particles that arrive before the light. Radio telescopes would tune in for the waves of energy released by the collapse. And across the world, humanity would look up, not in fear but in wonder. Because while the explosion would be vast and violent, we would be safe. Betelgeuse is close in astronomical terms, but far enough that its radiation would not harm us. No planet-wide extinction, no gamma-ray burst aimed at Earth. Just the rarest of spectacles, a supernova observed with human eyes. And perhaps, just perhaps, it will also change something deeper. In a world so often distracted by its own noise, the sudden, undeniable brilliance of a dying star could shift our gaze outward again. Could remind us that we are part of something greater. That above the chaos of our lives, the universe continues its silent, beautiful dance. That even in death there is beauty and meaning and new beginnings. As astronomers prepare for more advanced missions, Many hope that future instruments will be able to detect the gravitational waves and neutrino signatures that precede a supernova, signatures that would give us warning before the light even arrives. It's possible that in the coming decades humanity will not only witness a supernova, but predict one. That day, when it comes, will mark a new age in astronomy. But until then, we wait. And we watch. Betelgeuse, the red heart of Orion, continues to pulse. It flickers, it shifts, it whispers across time. Maybe the end has already come and the light is on its way. Or maybe it's still building, deep inside that turbulent core, fusing elements, struggling to hold its shape for just a little longer. Either way, when it happens, we will know. And when that light finally arrives, bright, overwhelming, unforgettable, we will look up and bear witness to one of the rarest, most majestic acts the cosmos can offer: the death of a star. The beginning of everything else.